Hello class. Yeah, now today we are going to start our mathematics for the new curriculum, and before we start I will first introduce myself. I'm called Wanyama Joseph. That's Wanyama Joseph. And I'm going to teach mathematics, and we are going to start right away from the first topic in senior 1. Then we shall move all the way up to senior 4, but we shall move in phases. Now, before we start, the name is that, and we shall learn math. Then before we start, I would like to inform you that a good student should have, if you are attending any math lesson, that means whenever you come for any math lesson, you should have the following requirements. That means you should have a scientific, not just a calculator, but it should be scientific calculator. Like there are many calculators, but the good one is FX 991 or FX 100. That's a very, and look for original calculators because many are duplicates. Now too, you must have a mathematical set with full instruments inside. Then to have a long ruler alongside the set. Also there should be a long ruler of about 30 centimeters in length. Then ensure that always a graph book is with you. And some lessons don't need a graph book, but whichever you need, ensure that you have carried a graph book. Then 2 pencils. That means 2 pencils must be in your set. And finally 2 pens. That's blue and red, and blue and black. Blue and black. Yeah. These are key to any student doing mathematics. That means never sit in class without the following. So now right away, without wasting time, we want to start with the first giving an outline of our various topics that we shall cover throughout the entire course of mathematics, knowing in mind that the key rule here, let me first list the topics here, then we shall have to see how to move. That means mathematics and the topics. And we are starting with senior 1 work. Senior 1 work from the first topic in the new curriculum. That means strictly today we are handling new curriculum, senior 1 mathematics topics. And they include, in term 1, you should have number bases. Then 2, you should look at number systems and integers and integers. Then 3, we should visit fractions, percentages, and decimal numbers, decimals. Then lastly here, rectangular coordinates. Rectangular coordinates in two dimensions. 2 dimensions we refer like a surface, like a blackboard, so that it shows only two what? It shows only what we call 2 phases of something, or we can refer them to 2 appearances of sides. Then term 2, we shall be visiting term 2, geometric skills and construction. And constructions of various. Then we shall visit number sequences and patterns. Sequences and patterns. Then we shall be visiting bearings. Bearing. Angles, general angle, and angle properties. General angle and angle properties. 5, we shall be seeing another area there called that is data collection and presentation. That's senior 2. That's term 2 rather. Then term 3, we shall see reflections. Then we shall also see, that means we shall see equation of line and a curve, then algebra 1. That means there is algebra 2. Then you have business arithmetics, that's your profits, losses, etc. Business arithmetics. Then we shall look at the time and timetable as the last topic, time and time table. Yeah, that will terminate the course of Senior 1 work, and immediately we finish this, it will directly throw us to Senior 2. But remember that in your primary, you had a slogan that mathematics is the key to success. Yeah, that's why we are saying that I was listening to a certain professor. She said that she left math in Senior 4 and thought that she had been done away with the so-called number things and symbols and looking for X. But when she reached in a higher institution of university, higher institution like university, she said that she found the monster again, that she had considered a monster. Yeah, she found it and she could not escape from her nightmare. Math is not a nightmare, it's just that people take it to be a nightmare. But math is a language, like you speak, like when you speak Luganda, we also speak mathematically, like we can say 2 plus 1 equals 3. That means I've only spoken using symbols. See, but it's if you make it part of your life, because it's everywhere, in walking, crossing the road. See, that's why some of you, when you are crossing with a friend, you realize that a friend can take a full 30 minutes, but a good the steps and the speed of the car, and by the time he has crossed, the car has not met him or her. See, that means allowing you to become mathematical is changing your lifestyle. Even eating food on the plate, you see, some of you eat and you end up with food only remaining without vegetables. You don't eat calculatively. So, a good mathematician will balance vegetables, will not ask mommy, add me some soup. No, that's all the math. See, now today let us see this subject, and you are going to see that it's actually what we have daily. See, and make sure when you live with this, you have become a mathematician. Now, number basis is our first topic for today, and I would like you to pay really maximum attention, and because some of these things is actually you have them but you don't know that you have them. See, number basis, basis, and under here we shall read some subtopics here, like what? Like meaning of a base, meaning of a base. See, meaning of a base. Yeah. Basis in real life. Do we really talk of something that we just think in the head, or we have basis but we do not know? The abacus. So then operations on basis, like converting to base 10, converting to other bases. See, addition, subtraction, and what? Multiplication. See, and division of bases, and that one will be the end. Will be the end. Now, the meaning of a base, I think request you to help me, because you know English, don't you? Yeah, you're good English. You're good students of English. Yes. Now, what does that word mean in regard to English? Meaning of a base. Then we can pull it across mathematics. See, what is the meaning of a base? What is the meaning of a base? I think we would like to hear from kirabo.
Okay, according to me, though it may not be right, but a base may be a number that determines something.
A base. That's what it means in English. A number in English.
It may not mean that according to me. That's what it means.
It means what? Say it again.
A number that determines something.
A number that determines something. Okay. Patience, could you say something? What's a base in English?
I think a base is like anything that is below.
Anything that is below.
Basement.
A basement.
Something like that.
Okay. Thank you very much. That simply, the word base means, like if we said the base of a cup, don't we refer to the bottom? The base is the starting part where the cup is seated. I think the word base means where to start from, doesn't it? Yeah, where to base from is where to start from. You're basing on which idea, you are starting from which idea, see. Now, a base is just a starting point in mathematics. And the starting point for what? Now, that's the question. See, it is in fact a starting point that many mathematicians, the ancient fathers of math, like if I gave you a list of oranges here, now we are trying to find out what's a base, not so? We said it was a word that ancient fathers got some many decades back. Now, if you are given those oranges to count them, ancient fathers tried to count objects, and the basis for counting, or the starting point for counting, was a what? A base. And what was actually a base? See, if we say to count them, what would you count? How many are they? There are 16. Eh? They are what? They are? How many? 16 oranges. Now, that counting, you see that your counting digits were what? That's the basis. You were basing on what? 1. You counted the 1 until you reached what? 16. But you see that in your counting, you had to count 5, 6, 7, 8, 9, 10, 11, then you reach 16. But in counting, you see that which ones seem to be our digits used in that counting there. Which digits are they? 1 is there, not so, but I can also see what? Your counting digits are only what? Do they exceed 9? No. It's just you keep attaching the 2 values or 3 to continue the counting beyond 9. See. Now, the earlier mathematicians just identified what we call a base to use it in counting. See. Now the first digits to be realized were 0 to 9. That means if you counted from 0 to 9, beyond the 9 you can't count. Before 10 was introduced, of course. For you, I think you are just thinking that they counted. Who knew that there was 10 now? Who knew? For us, we just find that there is a 10, but we don't know. Now, they tried to count 0 until they ended on 9, and there was no further counting. Now, let me ask you, in case you count from 0 to 9, how many digits are these? There are 10 digits, not so? Now, if there are 10 digits there, how do you now count beyond to reach 16? Assuming you are only provided with 0 to 9, how could we count to reach 16? These people did not have 10, 11. Let me hear from Patience.
I think they got 1 because it's a counting number. And they had to add on 0, 2, 3, 4. They had to use the first counting number. So when it reaches again 19, they will have to go to the second counting number and then they keep on adding like that. When they reach 20,
you are meaning that when I reach 1, I add 0? Assuming you are trying to find out numbers. That's what you're saying?
Yes.
That
they have to use 1 as the first counting number to reach the counting number.
Yes.
So I think they used the first counting number and they kept on adding whole numbers. And when they reach, let me say 19, after they've reached the last counting number, like 9, they will have to go to the next counting number and then they repeat the process.
How do you, if you count 1 up to 9, how do you arrive at the next?
You just get 1 and you add 0 because 0 is also a number.
Now, remember 0 hasn't introduced yet.
But still,
that means 0 had to come in to cater for some other place value. Okay. Now, let me fix you. Assuming you are only provided with 1 to 9 to count these things, how do you manage? There are 16, but you are only given 9 digits, excluding 0. Or we can include 0 to mean no orange, not. How do we count? How the student cater for this number and tell the person that you have given me this, I found this, using only those digits? Yes, Chirao. Somebody
if you are using only digits from 1 to 9, I think you can first count the oranges, from 1 to 9.
You count 9 over there?
Yeah, 9 of them. Then again you repeat from 1 to the number where the orange goes to. Then your other gets 16.
But how do you know 16 exists? You see, that's a bit tricky. Now, the system of counting now started to be done in groups. Patience claims to have said so. Now, they would count 9, put it separate group of 9, then go and count the balance, not so? That means you can count in groups. A system of counting in groups is what we are calling a base. A base is a system of counting in groups. Okay. That means we want to see something here, a bit tricky. Let us now look at the usual counting. The first counting was counted in groups of 10 before other groups can now be engaged in. Now, if you group in 10, the first group, assuming that these are how many? 16, not so? The first group has 10, not so? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I will be remaining with how many? 6. Now if these are 10 and these are 6, we see that this is one group of 10. This is what? 6. How many? This is one group having 6 individual what? Oranges. I want to show something here in to try to show you what we mean by a base now. Let me point you here again. If we counted in groups of 10, that means we are looking at base what? 10. Then if we count in groups of 8, that's base 8. Okay, we can't exhaust further. That means meaning of a base, I think you captured that as a base is a what? Is a system of counting in what? In groups. Could you have some real life examples of bases now? Yes, where are things seen in groups? Okay. Chirabo.
We can have a week.
A week.
Counted in base 10, the days are counted in base 7.
Base 7. A week is an example of real life. A basis example. What else? Example, then the base. You are saying that a week has how many days? 7 days. That's why you are saying that you are counting in base 7. Base 7 is in, that means to group, a group of 7 is just counting in base 7. Okay, that's good. Okay, let me hear from again Patience. Which other? A week is in base what? 7, because it's a group of 7 days. See, base 7. What else? Yes, Patience, you promised me an answer. I'm waiting for it. It's wrong.
Just say, okay, fine. Counting numbers from 1 to 9.
A group of counting numbers from 1 to? Yes. Why don't counting? Okay, counting numbers only. Counting numbers. That's in base what? You are saying from 1 to 9. That's base now. Which base is that?
9.
Base 9, because it's a group of 9. Okay. Yes, Chirabo?
Like a group of twins, that is base.
A group of
Twins.
twins. That's in base 2. A dozen of books. That's in base 12. Okay. Twins. Twins is in base what? Base 2. Groups of 2. Yeah. 12 eggs. Has how many eggs? 30. Yes, bases can go as far as 30, up to as much as you can count. See? That's clear, I think. People can have as many, not so? Yeah. Now, we want to see some examples of bases now, before that means we should first look at categories, then we shall look at the abacus here. A day. A day is 24 hours. That's exactly a group of 24. Yeah. Now I want to see categories of bases. Which bases have we tried to list here? Yes. Then the name of the base. You say the base what? Base 2? Do you have base 2? That's called binary. Then base what? Base 3 is called trinary. Okay, we can continue base 3. That's ternary. Ternary, not so. Base 4.
Queen.
Quaternary. Base 5. You mentioned the wrong answer. Quinary. Quinary base 6. Senary. I'll require you to really make research on this. Base 7. Yes, very much.
What do they depend on to name those bases? Okay.
To name those bases.
Like
Now-
the number.
Now let us first finish and we shall show you what do they depend on. Septenary. Base 8 is how many I've researched? Base 8 is what? Octo. 9? Nonary. 10 is decimal base. 11? 11 is? 11 is unidecimal. Then 12 is what? Duodecimal. But I will require you to add more. Hexadecimal would be which base is that? Hexa. Hexagon, from the word hexa. 6-sided is hexadecimal. 6 plus 10. 16. So, yeah, she asked, but this naming here depends on they are pulled from the number. They are pulled from your polygons. So nonagon. So, but the first ones, of course, retain. They have some original names which don't base on the number of sides. You don't have a two-sided figure, not so? Yeah. They just use their original names which are not dependent. But as you go on, you now bring in the dependency on the what? See? On the number of sides. Now, we want to go further and find out if you are writing a number in a certain base, which digits do you use? We saw that counting in base, in counting, ordinary counting of numbers like 1, 2, 3, 30, see, 30, 40. We can just refer something. They are small there because we want to see which digits, if in case a student is writing, when we say write out an example of base 2, which digits would you write? So let us speak it, that means digits used for each base. Then we got the abacus, digits used for each base. For each base. See? Now, Let me, before you can see, let me refer you to what we call the original system of counting digits. We said how many counting digits do we use? So we use 9, that's 0 up to 9. We are not saying they are counting numbers, no? Yeah. There are 10 digits, not so? But to me, let me, maybe somebody would be wondering, if there are 10, which base is that? These digits are used in counting base because they are a group of 10, not so? Yeah. See, yeah. Like now, if we wrote any number 234 base 10, see, because we said that you are counting in groups, what do we mean ordinarily? That assuming I'm counting numbers 12 base 10, I simply would mean that I have, we would now call in some concept there that I have two ones, then I have this position is standing for, this is actual 10 plus 2 as we move on. That's 10 plus 2. That means you have one group of 10 because we are counting in base 10. One group of 10, and how many isolated ones? The actual thing is that you will have, if you are writing 12 base 10, we are trying to explain here, you will have 10 things here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus another 2 ones here. See? Now that means in base 10, your numbers must not exceed what? 9. So, one group of 10 plus 2 ones. Okay, digits used for each base. We are realizing that the digits for a particular base, okay, if these are the digits for base 10, what are the digits for base 5?
0, 1, 2, 3,
up to 4. They must be 5, but you realize that you should not be equal to your number. Can 5 be a digit for base 5? No. It means the digit must be lower than the base, not so? See? Because if we include the 5, there will be 6. That means you will be counting in another group, not so? These are 10, that means counting in base 10. This is digits for which base are these?
7.
Because they are 7. Have we missed any? That is 3. Yeah. That means our what? Our conclusion there is that digits for counting any base must be less than the what? The base, and must be the same number as the base. Did you understand what I'm saying there? Must be the same number as the base, or it must be a group of the base. See? Okay, that's fine. Base digit, you'll highlight that, not so? Base 2, you'll fill in. This uses 0 and 1. Base 3, you'll write up to base 16. Now, me, I'm interested in this is using this. I'm throwing you to base 11. What will base 11 use? See? And remember that in writing out the digits, you don't write 2. Did you hear that? What do you mean? 11 would use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, You see? Now, because we can't write this, it's more better to represent using one symbol. See? That means 10, 11. Now, others would be lacking symbols. Introducing some other letters after 10, you can use A, B, C, D, E, etc. Or after you writing T and E for 10 and 11, you can now start in A, B, C later. See? That means when I write, now examples here, if we say to give an example of a number in base, examples of numbers in base, maybe if I say give me a number in base 3, how would you give me one number there? 2 what? 2 1, maybe 0, base what? 3. What if I said give me a number in base 12? 6, assuming a candidate was given like that. That's base what? That means you'll be understanding that T is 10. See? That T is 10. Yeah, now I want to take you now to the abacus. We now want to represent a base on the about. How do we, maybe somebody might not be, if we say read this, how would you read? See, reading base numbers 2 1 0 3. How would you interpret that? If you say interpret the meaning in terms of speaking in groups, because we are counting in groups of 3 3, not so. How many, which groups are in each place there? See? Yes, Chirabo.
In the first group there are 2.
In the here, yes. There are what? 2. They are 2 what?
200.
You see, you are counting in groups of 3 3. That means you have 2 groups of 3 objects. See, that means you have one group and another group. But here you have one group of 3. See, whereas in the first place you have nothing. That's the meaning. It just means the digit means the groups. See, 2 groups of 3 3. That means we read this again. We can read it as 210 base 3, or 210 base 3, or 233, 13, 03. That's funny. See? Yes, okay. Somebody has a question here.
You see?
Yes.
10 can be written as T.
Yes, that's
How about
exactly.
12?
That's it. That's now we said when you lack symbols, you introduce A, B, C, D. That very fine? So now we are saying, we are just highlighting on reading a base. 478 base 8. Is that student correct? The student is wrong. Why?
Because the 8 can't be D. It cannot be a base of itself.
That means if you included in a set of 8, you find that 8, the set of the group of 8 digits ends on what? 7. See, that means that would be a wrong group for 8. See, that means you would put another digit, not so. How do you read that and the meaning?
475 base 8.
475 base 8.
4 groups of 8 objects. 7 groups of 8 and 5 groups of 8.
There you are here. Now we are now going to highlight here how many groups? 4 groups of 8. See. Now we read it as 488. That's another one. Let us read 475 base what?
8.
Base 8, or we can read it as 488, comma 7. How many 8s are in this position? 7, 8. Now these are 2, 8 and 8, then 8. Then will you have another 8? No, 5 1s. That means you don't have a full 8 group. You have a group, but it has only 5 items in this place. See? That's why you read it as 5 and 5 1s. Now that one, keep that at your attention, because it would cause us to speak about place value in the topic called the numbers. So I want to leave with this. Now on the abacus. Now the abacus was a simple tool, and I'm going to request you, the abacus, you go and make an abacus at home. You use it for multiplying numbers. This is your assignment. You are going to design a number. Of course, you look at let me first highlight. I want you to go and get an abacus and use it to multiply and add numbers. See, you can multiply as big as any. I'm going to require you to go and study. The abacus was an earlier tool used by traders. See, the earlier mathematicians did not have a calculator. How did they add digits? See? Now, you see, life was hard those days. Now they had an abacus. And an abacus had a list of what? It was just a simple tool for carrying out simple mathematical operations. And how do you represent the digits on the abacus? It's simple. 2, 1, 3, base 4. Representing bases on the abacus. Representing bases on the abacus. It's a very good tool. If you learn how to use it in multiplying, you can even multiply in the head. See? You can multiply these digits in the head, but while having an abacus, a diagram in your head, or an abacus that you have designed in your brain. See? That's how great math was those days. See? So interesting. Now, when you are designing an abacus here, we just we can ask you to go and make one at home. Go and see. You can go to machineries, those who deal in timber. They do what? They design for some pieces of wood, and they design for you a rod and a rod and a rod. See, then you can make some balls using soil. You know, those balls you can make clay and make some balls. You make a ball, you put a hole inside. You arrange them. See? You arrange them like that. Then go on YouTube and type in multiplication of numbers or addition using abacus. Study that. See? And you use your mental abacus. But for us here, we just put as we see. That when we see 2, we put how many? 2. When you see 1, you put 1. When you see 3, you list 3 of them. See? Yeah. This is it, 2, 3, 2, 3, and what? And what? And 3. Now this is a place for 4, 4. 2, 4, 4. This is 1, 4. Not so? Yeah. This is 3 what? 1s. But we shall later give it a place value, the place value in a better way. But since we are in bases, we can't over exhaust. Yes, you're excused.
Don't you think they have to settle at the bottom? Okay, not coming there.
Sir, let me ask myself that same question. Sir, don't you think those balls have to settle at the bottom? Let me ask you also. In reality, if you had what? An actual abacus and you have put your soil things, they will settle, not so? But you can design in a way that some can be made to hang somewhere for the counting purposes. But as for now, they settle at the you say they settle at the what? They sit on each other, not so? Because this is an actual thing. Thank you for that. They sit on each other. But using an abacus to multiply and add, you realize that some might hang in space for the reasons of you design it in such a way that it can hang somewhere.
That's the use.
An abacus.
What's the use of putting them to settle down? And yet the whole reason is to count. They can be counted even when they are settled. And even when they are spacing.
But then it's automatic. If maybe you have created the holes and maybe there are that clay thing you have made is dry, it will just go to the bottom.
No, what if it's still wet?
Why should you use a thing that may even break your
No. Seriously, it's not.
It goes to the bottom.
Listen. Just put the thing in reality. We are doing the abacus so that we can count the balls, not to let them sit. Okay?
But still, you can count them as they are still.
No, I'm saying not count them in their space.
If they are space, you make your own, develop your own that will be.
That's why I'm saying what's the use of doing all that. Even though it's in space, you can count it, right?
Yeah, but even if it's settled, you can count it.
Now, let me show you something on the abacus for you to maybe pick the meaning very well here. Let me use a base 10 value, because it's better to understand in base 10, ordinary numbers. Remember, when I write it 24, even if I don't put base 10, it's already in base 10. Now, on your abacus, you would be putting these two, not so? And here you'd be putting what? 4. She wants them to settle. It's a good thing to do it. But I'm asking you to go to YouTube. You see how an abacus can be used in multiplying digits. Now I want you to look here. This is 210, but this is 10 and this is 1. Not so? Now look here very, very well here. We say the meaning of this, it means 2 groups of what? Of 10. 2 groups of 10 would mean what's the total number?
21.
20. That's why it would be 20 plus 4. Not so? Yeah? See? Now, if you are in the base 4, this would be 2 groups of 4 in this place. See? Which is being represented by these two groups of 4. Let us leave those things. You go and research more on the abacus. See? Let us drop to operations on bases and see. That's, you see. Now, there I think you are the ones who are going to guide me well or not, so? See. Before I shift here, operations on bases, and we are starting with what? Converting from other bases to base, other bases to base what? To base 10. So now there I would again refer to that one. We shall directly go to examples, not so? Convert each of the following to base 10. Yeah. Now we start with the say 1 1 2 base 4. See. Do you have ideas? And would you explain your idea when you guide us?
Yes.
Yeah. Yes. How do you achieve that?
First expand.
We first expand the number. How do we expand the?
You expand it in form of bases. Like 2. Okay, we use place values actually.
We use place value. This one would use place value of
1. Then the next one we use the 1 for the base and it's
1 4, not so?
Yes. Then
How many 4s are here?
2.
That means the 4 and 4. Now that would now mean 1 1 2 base 4 would now become 1 times how many 4s? That means this place takes on 4 to power 2. There are 2 4s. Then this place takes on how many? 1 4. And this one takes on 1s, which is any number to power 0 is 1. That would mean you'd have 1 times 4 squared. Not so? Plus 1 times 4 to power 1 plus 2 times 4 to power
0.
Okay. Now that gives you 1 times 4 4 as the issue said here. Then then this is 1, not so? See, giving you 16. Is that 16?
Yes.
Plus 2. That gives you
22.
22. Base 10. That's exactly. Yeah. I will not hesitate to. I think I will put a tricky one there for you. This one, let me use 8101. Which proper base can I put there? I put 9. Yeah. That would be very big on the calculator, because it would have many 9s. Let me reduce it for you so that we enjoy. Big ones, you'll do it then for yourselves. How do we convert that one? This one would have 9 to power. But the base, since I brought it very low, why not use a lighter base? Like base 3. How many 3s are in this place? That means 3, 3. Here I have 3, 2. Here I have 3, 1. Then here I have 3, 0. Yeah. Yeah. Now it means you know what to say here. This is the 3, 3, 3. Yeah. And that's how you speak in bases. I want the answer from you. Then incidentally somebody would try for us a T2. T2, this base would be better base. I'm waiting for you there. You have got 4, 6 base 10. Oh, 4, 6, 4, 6. Okay.
No, it's wrong.
It's not correct.
I made a mistake. I've got 6, 4.
6, 4 base 10.
Yeah.
Okay, we can add mentally, but since you have done it already, fine, that's great. What of that? Which base is proper there? T2.
Base 11.
Base 11. That means this part would be 11 to power what?
2.
To power 2. That's very massive for you. Now you need a calculator. Whereas this is 11 to power. This guy, Chirabo, you have deceived. This is 11 to power
1.
1. Yes.
Sorry.
Yeah, she directly deceived us, not so.
I didn't.
Therefore, this would be T. This is how many 11s are here. This is 11, and this is 1. Clear?
Yeah.
And that would mean you have T times
11.
plus 2 times 11 to power. Now this one you would bring it. This is 12. This is what? 10 times 11
100
plus
22.
plus 2 times 1, giving you 100 plus 2, which is 112 base 10. Base 10. Yeah. Now we are moving to now converting from what? That means somebody who can write this 11, see, into some other form. But that's pretty easy. See, we can now go to converting. Are we clear? Now let us convert from what? From base 10 to other bases. Yeah, that's okay. From base 10 other yeah. Now you need to listen. Converting from, since you seem to be so clear to other messages, you seem to be very acquainted with it, to have known it. That means 24 base 10 to base 2. Somebody, how do we do that? How do you arrive? Yes, guidance from Chirabo.
We shall use some kind of table that will have...
Some kind of a table that will have? Base. Number. Remainder. This is which base? Base 2.
Yeah, the base should change.
Then the number is which number? 24.
Then we
24 divided by 2. We get 12, remainder.
0.
Okay.
Divide 12 by 2 once again.
Then 12 divided by 2.
No. Okay. Yes.
12 divided by 2.
You get 6.
6.
Remainder 0.
Remainder 0. Then
6 divided by 2.
6 divided by 2.
You get 3.
You get 3.
Remainder 0.
Remainder 0.
Yes. Yeah, then 3 divided by 2.
Then again by 2.
You get 1 remainder 1.
1.
Yeah.
That means what are you having? You write from in the middle here.
No.
You write from here.
No. That's where we started from.
From here,
Yes.
you go like this.
Yeah.
That means you'd write it as 24 base 10 is equal to
1 1 0 0 0
base what? Base 2. Are those zeros important?
Yes. Yeah.
They speak of place value that we shall see ahead. That means you do not require me to do very many examples. I think you are trying for me 66 base what? Which beta base is that? 66 base? Base 10 to base? Take for me to base, at least base 5, not so. Yeah. That means you must write from the middle here until you finish all the remainders. Let us prove you. We've got okay, let us start here. 66 divided by 5.
13.
How did you arrive at that very fast?
Because 65 is the nearest to 66.
To 66.
Yes, and the remainder would be
13. How do you explain in a simple way to somebody? 6 divided by 5 is 1 remainder? 1.
yes.
Then this creates 16 divided by 5.
You get
3 remainder? That calls in that logic. That means you get 13 remainder. Well, let us divide again. 13 divided by 5.
2 remainder.
2 remainder 3. 2 divided by 5.
You get
It is lower than the base. Therefore, we just have the answers. 2. Did you say 2, 3?
I said 2, 3, 2, but I made a mistake. It had to be 2, 3.
2, 3, 1. Then that will be 2, 3, 1 base 5, not so? Yeah, now we want to convert from another base to another. I think we are doing what you know. Is it what you know?
Yes.
It's from primary, not so?
Yeah.
You're a very good student in primary, I can see. Converting from from other bases to other. How do we arrive at that? To other bases. How do we arrive at that? Do we yes, Trav?
We shall have to first convert a base to base 10, then convert from base 10 to the base that is required.
First convert to base what?
Base 10.
To base 10. Then from base 10 to the required base. That's, I think, so understood. Now that means examples convert that is 2, 3 base 4. Now you are taking it to base 3. You said how do we arrive at that?
First convert base
To base 10. How do we take it base 10 then first? This one uses 4th power.
1.
Then this one uses 4th power. 0. That would mean 2, 3 base 4 would be. I also request that a good student underlines every answer. Speed and accuracy is part of a mathematician. Neatness, overcrossing is highly prohibited. Yeah, now we have 2 times 4th power, not so? Plus
3 times 4
4th power 0. Then that would be 2 times 4 plus 3 times, and the number power 0 is 1, not so? That gives us 8. 8 plus 3 is base 10. See? Now you said after this, what do we do?
We change that 11 base 10 to the required base.
To the required base. That means you have your base, the number and the remainder. Somebody has already done answer? What is the answer? 102 by 3. Let us test. 11 by 3.
11 by 3, get 3, remainder 2.
3 remainder 2. Then 3 by 3.
1 remainder 0.
1 remainder 0. That means you are getting your answer as 1 what?
0 to base 3.
Yeah. That means 23 base 4 is 102 base 3. I think that's pretty easy. Yeah, that means you'll find many in the exercises. Let's turn to adding bases. Adding bases. Yeah. To add the bases is to add different groups. Did you hear that?
Yes.
Yeah. To add in different groups. So, but it is wise to add groups which have the same number of items. It's not wise to add groups of 5 to groups of 6, groups of 7. It will be a bit tricky. It's better you add groups of 4 to each other, then you'd easily add, like adding one group of 4 with another group of 4. See, that's why addition of bases must have numbers in the same base. See, like add each. Like if you add 2, 3, 4 base 5, and you are using 1, 4, 1 base 5, and you are trying to add, that means you cannot add 1 in base 5 to 1 in base what? 6. It will complicate the places where those items are. See? That means if you are adding in different bases, you must agree and convert one base before you add. Like if you add base 5 and base 4, you will decide. Or either take all to base 10, add and return them, or else take them to one base before you add. See? How do we now add here? Yes, I would want patience you guide as you guide as we add. Or you come and illustrate, you add as you explain, if you are ready. The calculator and the blackboard, the whiteboard is here. You want to just explain? I wanted you to come and explain how you are adding it direct here. You tell us, you teach also. Patients, come and teach this. Come and teach.
Okay. 4 plus 1 will give you 5, and get every base. You cannot put the base in the number in its own base. So you will have to divide 5 divided by 5. Let's put here our cyber. 5 divided by 5, you will get 1 remainder 0. So you put the 0 here. But remember, our answer is in base 5. So this one, you'll have to carry it here. 3 plus 4, you get 7. And I think this one didn't. It's not there. 7 divided by 5. 7 divided by 5?
1 remainder.
Good. So you have to try the remainder here. 2 plus 1 is 3. That's in base 5.
Is she correct?
No.
Your sister said no. What is wrong with her work?
Okay, teacher, after her adding 1 plus 4.
Yes.
And she got 1.
1 plus 4? Yes, 1 plus 4 is 5.
So when she divided 5 divided by 5, she got 1 remainder 0.
1 remainder 0 and wrote 0.
And she had to carry the
1 here.
The 1. And she rejected it.
To have 80, that means you make it 8. Divided by 5, that gives us remainder 3. Therefore we carry 1, and this would be 4, not so? Yeah, that's great. Okay. Now I would put 3 of them here. 8, 8, 7 base 9 added it to 7, 1, 6 base 9. Then that means I want comments there. And I also have T 1, 2, 4, 6. What is this base here?
11.
Base 11, then also base 11. How do we add now? We need guidance here. This one, guide us here.
7 plus 6
is
we get 13.
Divide by 9.
We get 1 remainder 4.
1 remainder 4. We divide because the answer is bigger than the base. You divide when the answer is either equal to or bigger than the base. Here you said we get 1 remainder 4. Therefore we carry 4. That gives us 1 plus 8 plus 1 is 10.
Divide by 9.
We get
1 remainder 1.
1 remainder 1. Therefore we write 1. We carry 1. Then that is 9 plus 7.
We get 16.
16 divided by 9.
We get 1 remainder.
16 divided by 9.
We get 1 remainder 7.
We get 16 divided by 9.
1 remainder 6.
Get 1
Remainder 6.
remainder 6. That very correct.
Remainder 6.
What do we get there? 7. That means we write 7 and carry 1, not so? But there is no other digit, therefore. Yeah, then I think somebody will disregard on this one. That's pretty easy. What is the answer here? 1 0. You didn't want to maintain that since it has no 1 0. Subtraction of bases. Yeah, I need more guidance. I think this time you are coming to subtract. How do we subtract? How work out each? How do we subtract? See, then we got something else. 4 3 1 base 5 and 1 2 2 base 5. How do we subtract that? Yeah. You come and guide us, Chirabo. Are you ready? Maybe. Okay, we can now.
Okay, since this is base 5, so we have here 4 3 1 base 5 minus 1 3 2 base 5, and we shall start with 1 minus 2, which is, okay, we can't subtract 2 from 1, so we shall have to borrow from the preceding digit, that is 3. And which number shall we borrow? We shall borrow 5 because this is base 5. Let me hope I'm right.
That you borrow one group.
Yeah. So we shall borrow here. We shall remain with 2.
Because those are 3 groups, you are borrowing 1 group.
Yeah.
Okay.
Then here it will make,
It would be?
I think we shall have to borrow 10. I'm not sure.
You are not sure?
Yeah.
Okay, try to borrow and we see. What have you borrowed?
Okay, if I'm to try borrowing 5, so it's going to be 1 plus 5 that I've borrowed to get 6. So we shall subtract 6 minus 2 to get 4.
To get 4.
So here we shall have 4. And then there we have 2 minus 3. So we shall also borrow. Here we shall remain with 3. So we shall have 2 plus the 5 that we shall have borrowed to get 7. And we shall have 7 minus 3 to get 4. So here we have 4. Then 3 minus 1. I know Patience can fail that one, but...
You know Patience can fail that one.
Yeah, because it is very hard for her. This is base 5. That's according.
Is it very, very true that that Patience, it is, she has not accepted, not so? Okay, but I think that's very good idea that when you have a less number, then you have to borrow a group, because each section are just groups. Like these are 3 groups of 5. You borrowed 1 group of 5 to put here. See, that means you are borrowing 5 things. Okay, that's great. I think people are very, very clear with subtraction, and I don't see any big query there. You just have exercises and you do respectively. Or try out this maybe. Let me give you a try on this. Part B. Yeah. 7, 1, 2 and 6, 8, 8. Could you try out that in base 9 each? In base 9. You try to subtract and you'll give us the answer. Yes, Chiraba, you have the answer?
Yeah, I've got 2, 3 is 9.
2, 3, 2. Here there is nothing.
Yeah.
0, 2, 3, base 9.
Yeah.
That's great. That's correct. This one, okay. You borrowed the 9. That created you 11 minus that is 3.
Yeah.
Here it's 9 minus, here there is 0.
Yeah. Then you borrow.
You borrowed the 9. 9 minus 8.
It is 1.
1. Yes. Okay. Yeah.
Therefore your answer is incorrect.
Mine is correct.
Yes, your answer is is which answer, Patience?
I got 0, 1, 3.
0, 1, 3. Oh, she had said that you don't know. But
Teacher, I just said that.
But that's not what I meant.
oh, you meant that oh, okay. You didn't mean that.
Yeah.
Okay. Yeah, now we can proceed to multiplication. I think that's great. Multiplication. How do we multiply? Now multiplication, we multiply like we multiply usual numbers. But remember that you'll never write any answer greater than the base. You have to carry out division. That we multiply normally multiplication in bases. See, we said work out 244 base 5, and we are going to multiply it with 2, 3, the same base 5. And we see how do you multiply. Anybody, you are sure? You are sure? Patience, are you very, very sure? To multiply, you're very, very sure. You're very, very sure. Okay, let me have some. Come and explain. Patience, it's your time. You'll be very loud. You are not willing to explain. Okay, guide me. Guide me. I will say
4 times 3.
I will say 4. I will say 4 times 3.
It's 12.
That means it's 12. 4 times the 3 is 12, not so?
But 12 is bigger than 5.
Yes, 12 is above.
Divide.
Yes.
We have to divide 12 by 5.
12 divided by 5 would be
2 remainder 2.
2 remainder 2. That means we write it 2
And carry 2.
and carry 2. That's great. Okay, continue.
4 times 2.
4 times.
2 is 8.
Where are you? Where are you?
No, you're still
You finished this, not so? Then you are here.
Yes.
That is
Okay. 4 times
4.
4 times 3, sorry. Not
Yes, 4 times 3
is still short.
plus 2.
14.
Then 14, you are dividing by 5.
Yes.
That gives us
2 remainder
2 remainder.
4.
Are you very, very sure?
So,
That means we write 4. And again carry 2.
2 times 3,
6 plus 2.
8.
8 divided by 5.
Is 1 remainder 3.
1 remainder 3. That means I write 3.
Yes.
Then where do I put that one?
Just keep it.
In front. Okay.
4 times 3
Is 8. I write 8.
under 4.
I write 8.
Yes, under 4.
I write 8. 2 times 4 is 8. Are you very, very sure?
Hey, teacher, let's have us complete. I also have my own method.
Your own method. Okay, now we write 3. We carry 1 here. Now we know that I've carried 1. 2 is no longer there. Now, okay, continue.
4 times 2 is 8 plus 1,
9. 9 divided by
1 remainder 4.
remainder 4. Carry 1.
2 times 2 is 4 plus 1, 5.
5.
5, 1 remain. 5 divided by 5 is 1 remainder 0.
1 remainder 0. Therefore, I write like this. Is that finished?
Yes.
Then we carry out
Addition.
addition. Put here 0
Even there.
and here 0. What do I get?
2.
2.
7. 7 is more than 5, so we have to divide again.
I will have
7 divided by 5 is 1 remainder 2.
7 divided by 5 is 1 remainder 2. I write it 2.
Carry 1.
I carry 1.
So 3 plus 4 is 7 plus 1, 8.
8.
8 divided by 5 is 1 remainder 3.
1 remainder 3. I carry
1 plus 0 is 1 plus 1,
is 2.
1.
Then 1. Base 5. Silava, you said you have another alternative.
Yeah, but okay. Never not to give us the same answer.
You want to illustrate it here?
No, you can't. I'm not sure you can tell yes, right?
You tell me as you guide me. I wanted you to explain. I might not be knowing it, maybe. Okay, that you have an alternative 2. Let me see. Let me see, maybe it could be better or wrong or correct. Okay. Guide us and we see. What are you going to do?
Okay, we are going to multiply, just like how we usually multiply these numbers of base 10.
Yes.
So it's going to be 3 times 4, you get 12.
12.
Put 2.
I put 2.
1.
Carry 1.
Yeah.
Yes.
3 times 4 plus 1, that is 9. I mean
13.
You write 3 carry 1.
Carry 1.
Then 3 times 2, that is 6 plus 1, that is 7.
7.
Yes, then 2 times 4, that's 8.
That's 8.
Yeah, below 3. Then 2 times 4, that is 8.
8.
Then 2 times 2, that is 4.
Is 4.
Then now adding is when you start dividing.
Let us continue. What do I do?
2 plus 0, you get 2.
Is it 2?
3 plus 8, you get 11. 11 is more than 5, so you are going to divide.
We get
11 divided by 5, you'll get 2 remainder 1. So
2 remainder 1. We carry 2.
Yes.
Yes.
So 8 plus 7, that is 15. Plus 2,
Plus
that
2.
is 17. Then 17 divided by 5.
Gives
3 remainder 2. You write that 2 and carry that 3.
and carry the 3. Okay.
Then you'll have 3 plus 4, that is 7. Divide by 5, that is 1 remainder 2. So it will be 2 and then the 1 in front.
Like this.
That's 5.
That's 5. Who is wrong? Chirabo,
That's your idea.
no, me I also want to know. Who is correct, who is wrong?
Teacher, in this slide,
Now-
everyone wishes to be the right one. So
Hey.
mine is right.
Now the proof is easy. You convert, if you have time, convert to base 10, convert to base 10, multiply, then convert to base what? If your answer, which answer would be correct? That means first take this to base 10, take this to base 10, multiply like ordinary numbers, then convert to base 5 and see. If your answer is correct, then you are the most correct. Are you trying to convert to base 5? To base 10? Then multiply the answers in base 10 and reconvert to base 5. Because now we are yet to want to go to division. Who is correct? Mathematics is the key to success. Which answer is coming out? This one or this? This one. Yeah. Because you see, when you don't try to divide as you multiply or you handle any property, you are affecting the groups of items in the next place value. You see that? That means they are being affected and they will bring confusion in the groups that have been arranged. Now let us go to division. I hope. Do you want more highlight on multiply? Oh, you multiply for me. 44 base 6 times 55 base 6. Remember, speed and accuracy are part of a mathematician. 2 minutes. That means you are trying out to 44 base 6 times 55 base 6. We shall also call in private
I've got 1012
1012 base 6. That is 4455. Any order, whether the other one is up or the other one, it's fine. It's 20. So now you have the same answer.
No.
You get 20. 20 divided by 6, you get
3 remainder.
remainder to carry 3. 20, 23.
Divide by 6, 3 remainder 5.
3 remainder 5.
Okay.
No, teacher. It's 5 first, then 5.
3 this way, then 5. Good. This one is 20 divided by 6.
3 remainder 2.
3 remainder 2.
Yeah,
Okay? Then we carry 3. 23, not so?
yeah.
This one is 20 plus that 23
Divide by 6
is
3 remainder 5.
3 remainder.
The same
Same as up.
Like that. Then we add, not so?
yeah.
That would be 2.
Then 7 divided by 6, 1 remainder 1.
1 remainder 1.
Then 9 divided by 6. It gives us 1 remainder 3.
1 remainder 3. Gives you 4 base 6.
That's the answer.
That's the answer you got. See? Yeah, that's very great. Now, in the case they gave you different bases to multiply, maybe multiply base 4 with maybe 1, 2 base 3, and give your answer in base 5. They give you, okay, you first remove that, try of yourself. At 2, 3 base 4 times maybe 1, 2 base 3. You said here, what would you do?
I would first change base 4 to base 3.
You change it to base 3 or vice versa. Then after getting your answer, the question said take it to base 5.
What if you could rather change both bases to base 10 at once? Okay.
Then you multiply easily.
And then you multiply and after all change from base 10 to base 5.
It works. But remember, in math, a number can be done through many routes. As long as the root is not gambled, then it will be correct. Let us go to division and we close. Division of in bases. Division in bases. How do we divide? How do we divide? Yes, Chirabo, explain how we divide.
I think we can change bases, different bases to base 10. And then divide this. If it's of the same base.
Let me pick for a number here to divide. Say, explain as I pick for a number. That you? How do you carry out division?
You change to base 10.
You first change the numbers to base 10. Then you divide and return it back. That's very great. Yeah. Let me put it for you here. That we first change the both to base 10, then we divide them because base 10 is ordinary numbers. Yeah. Let me pick this one for you. Divide 001 base 2 by 1011 base 2. Okay, let us have that one. I hope that is there is a 0 here. You are claiming that we first take them to base 10, then from base 10 we divide them, then return them to base 2. That's great. Yeah. That means, how do we arrive at that? You are guiding me, not so? How do we arrive at that?
You shall have to apply the power.
The power, this is to power. Power 4. This is to power 3. This is to power 2. This is to power. This is to power 0, not so? Yeah. That means I will have, let us multiply and we see, we shall have
1 times 2
power 4 plus
1 times 2 power 3
plus
0 times 2 power
2 plus
0 times 2 power 1
power 1 plus 1 times 2 to power 0. Yeah, that gives us 2 is appearing 4 times, not so? Then here 2 is appearing 3 times. That clear? Yes, I can see somebody rushing through it. That's good work. That's good. That's good. 2 times 2 times 2 times 2 gives us 16 plus 8 plus 0 plus 0 plus 1, which will give you 15 base 10. Then we go to this other number.
General comment gives us 15.
This is 16, not so?
Yes.
This is 8. This is
0.
This is 0. This is 1. This 25.
25.
I like that attention. That's 1 times 2 to power. Yes, I'm waiting for your answer again. That gives you 2 times 2 times 2 plus 0 times 2 times 2 plus 1 times 2 plus 0 times 1. And that gives you 8 plus 0 plus 2 plus 0. Base 10. Yeah. To remainder 5, I will show that 0, 0. I think I forgot one digit here. Could you cater for that? There is an error there. There is an error in my number here, that's why. Please improve it, sorry. 2 to the power 5, 2 to the power 4, sorry. I think it's easier to only have this step corrected, because that was an error in copying. It would be complicated in the division for this number only. That has a problem. This is to the power 5, this is to the power 4. Then this is to power this is to power 3, power 2, power 1, then plus 0, power 0. Means I needed another. This is 2 5 times 3 4 5 times 1. Okay, here we are very sorry, we wrote incomplete digit. Because an error in the number, of course, makes the number a bit looking fierce, though it's not fierce. That will give us 32 plus 16 plus 0 plus 0 gives you
40. It's 50.
50 base 10.
Yes.
Yeah, then we are going to divide it by the next answer here.
50 divided by 10.
To base 2. That means I'm now going to have 50 divided by 10. Or because this is easier, 50 divided by 10, you are getting 5, not so? That means you again now 5 must be changed to base 2. Must be changed to base 2. That means you have a number, base, remainder, that's 5. 1, 1. 5 divided by 2 is 1 or 2?
It's 2.
Remainder? 1. That will now give you 2 divided by 2.
1 remainder 0.
1 remainder 0. And now that digit would be base 2. Yeah, now you come and tell us here that this divided by this gave us 101 base 2. Yeah, that is very great. I think also we give somebody here a number to try. You are ready? As a closing number, divide (104 base 5) by, by that, yeah, you are given just 3 minutes, then we close away with the activity of integration. That in division we first convert to base 10 everything, then we divide and return it back to the ordinary, to the required base, the required base. Make sure you have the answers 401 base 5, 40, 40, 40.
101 divided by 5, you get 20 remainder.
Are you sure? 20 remainder 1, 20 remainder 2. 101. I think you are trying to steal from a calculator, not so? You are trying to steal 101 divided by 5 on the calculator. It gives, did you see what it gives you? It gives 20.2. This 2 is not a remainder. It's a certain fraction which has remained that you need to see. Divide by long division and see. Yes? You've got 401? Yeah, I think divide well. The calculator will give you this. But what if you are stealing the answer from the calculator? Let me show you how you steal it. If you are fearing to use long division and you want to steal from the calculator, you do like this. You are trying to divide the 101, not so? Yes. By 5. Yes. Put it direct on the calculator. 101. Let us put it in long division better. Okay, let us guide you and we close. Divide direct. It gives you 20.2. You write what? You write only the whole number. Multiply it. You'll get 100. Subtract, you get. That's the remainder. 401. That's 5. That's great. Okay. Have this activity of integration. Are you ready? A community is hit by famine. A community is hit by famine. And the government the government decides. And the government decides to give each member in a household a potato. Decides to give each member in a household a potato to solve their problem of the hunger. Solve their problem of the hunger. Paragraph. Each package contains an equal number of potatoes. Each package contains an equal number of potatoes of 5. Then the other paragraph. Each package contains an equal number of potatoes of 5. Then the other paragraph. There are 10 households in the community. There are 10 households in the community with 3, 5, with 3, 5, 7, 4, 6, 5, 8, 12, 13 members respectively. Determine paragraph 3, 5, 7, 4, 6, 5, 8, 12, 13 members respectively. 3, 5, 7, 4, 6, 5, 8, 12, 13. Yeah. Determine the number of packages of potatoes the government. Determine the number of packages of potatoes the government will take to that community in case, full stop, continue. In case there are remaining potatoes, discuss what the government should do with them. Full stop. And you'll discuss as a pair. You'll be guided later during the discussion for this question. Thank you very much. We'll meet in the next topic.